So the overview I want to talk about tonight is the background, where I came from, what I'm currently doing. What has machine learning been like the last decade? It's worth talking about that as to what's been happening recently. Why I've seen machine learning projects and teams struggle and also fail. More detail about MLOps, the workflow, showing you a demo of what the MLOps pipeline would look like within development and production, and then going over some best practices. And as I mentioned before, at the end of each section, I'm going to be looking in the chat and seeing if people have any questions and answering them. So my background, for those who don't know me, is that I'm a senior ML engineer at Cured, and we are a healthcare startup with the goal of providing you access to better healthcare. In the past, before I ended up working at Cured, I was working at an online dating startup called Meet Mindful out in Denver, and I was hired as the first and to this day the only data scientist that they ever had. And I became what I would call a full stack data scientist. It's not a term you hear often, both on LinkedIn and in job descriptions. But through my time there over nearly 2.5 years, I was responsible for developing, deploying, and maintaining each of the machine learning projects that went into production. And this was as small as doing some of the analytic work that needed to be done, all the way up to building out the recommendation system that powers the dating engine. In 2019, on top of that, I ended up becoming responsible for the cloud infrastructure. I had more background with Amazon Web Services than the engineering team, so I ended up starting to advise on better practices and realizing that there was a lot more than people weren't talking about with respect to machine learning infrastructure and really what does it take to get something out into production. Within that, and within Be Mindful and beyond that, my general emphasis with what I do is recommendation systems and GPU computing. So recommendation systems are things you'll be seeing a little later tonight in terms of what goes to production. And GPU computing is one I may give a talk on at another point, but in short, it's really how to make machine learning incredibly fast across a large amount of data. So to kick this off, I want to talk about the state of machine learning over the last decade because it's worth discussing where we were and where we've gotten to. So if you end up looking back, starting around 2012, the Harvard Business Review published an article called Data Science, the Sexiest Job of the 21st Century. And this was an article that started to expose more about what data science is, what machine learning is, and started to bring it to a broader audience. Now, within that timeline, from there on out, you had services like Docker and Kubernetes got released, and around that time the article got released, there was a massive hiring spree that happened within industry, but as you see on the slide, there were also growing pains that happened within that time span as well. Now, the largest growing pain that you'll hear me talk about tonight is how you go to production. More on that later. Industry seems to realize at this point that data scientists are really, really good at developing models. They're really good at doing analysis, but they have a lot of trouble going to production. So around 2016 is when you start to see the title of machine learning engineer start to circulate a little more, both within LinkedIn, even within Google Trends, if you like to go and check that out. And the idea was we want someone who is a combination of a software engineer and a data scientist, generally because software engineers have had some level of experience going to production. So this starts to take a hold within industry, and there is yet another hiring spree, but again, there are growing pains that start to happen with it. Even with the automated platforms like AWS SageMaker, you have others like DataRobot and driverless.ai from H2O. There are still a lot of issues with getting something to production, much less maintaining it, updating it, and being able to monitor everything that goes on. And that brings us to 2020, where we start to see MLOps start to be discussed in more detail. It has been discussed before now, but it's starting to gain more traction both within the industry and within social media, if you will. So to that end, people have heard me talk on the presentation right now about the struggle that machine learning teams start to face. To that end, the question I get a lot from people who meet with me or I get questions about is, why do machine learning teams struggle? It's a combination of a number of things, but I've boiled it down to two major items. It's the lack of experience, exposure, and emphasis. Breaking that down even further, when you start hiring a machine learning team, you need people that have experience, preferably within the area that your business wants to make the impact in. With an exposure, the exposure is in relation to what type of problems they've either faced before or what they've been doing in the past. The same goes with emphasis. If you haven't been exposed to the problem before, it's going to be considerably harder. I'm not saying that the problems can't be completed. I'm just saying it will take you significantly longer in terms of time. And then emphasis relates into that just based on what they have done in the past. And a lot of this boils down to prior knowledge as well. The second aspect of that is leadership. A lot of the leadership right now, in my opinion, has been oversold on machine learning and the buzz term artificial intelligence. There's a lot of expectation versus reality within the industry where you have people who are either non-technical or technical, but not within machine learning, and have certain levels of expectations at what they think their data can do and what the models can do. And when you start having their expectations meet reality, this can also start to be a struggle both for the team and the business as a whole. So why do machine learning projects fail? What have I seen the last couple of years within my own projects and within my peer group? Well, the first one, hands down, is communication breakdown. I'm a believer that a failure to communicate is a failure to launch. And if there isn't communication within the organization, the project is not going to succeed. There needs to be a number of stakeholders within the project. And what do I mean by that? You have the machine learning engineers and the data scientists that are going to be doing the modeling and the analysis. You are most likely going to be working with software engineers to integrate your system into their own API and their own infrastructure. You've got leadership that also needs to be on board with this, because if they're not on board with it or not fully bought in, it's going to be difficult to get the project off the ground, much less get their attention to do more projects in the future. Scope creep is the second one that I've seen affect a lot of the projects. And what this means is that oftentimes the project starts within certain boundaries and it starts to expand at a pace that the team or the individual can't handle. This is not to say that they're incompetent. This is to say that it is significantly more work based on features that product or marketing may want added, something that leadership may want changed. The list of things goes on and on, but this leads to a rapid amount of items that need to get done, such that it ends up impacting the problem and not being in the sense that it can't have the model shipped. The third item is the tech stack. You'll hear me talk about this later tonight as well. But the tech stack is also going to be key based on not only what your team knows, but also what's practical for the job at hand. Very often, what I see a lot of organizations do that makes these projects fail is they want to buy in to a Python library or framework, thinking that this is what they need to do in order to have successful machine learning in the organization. A great example would be people saying that we need to use Apache Spark for data analysis, we need to be using TensorFlow or PyTorch to do deep learning, we need to be using things like Kubernetes, we need to be using all these other things. And what I've started to come up with in my head is that it really comes off as a political development decision as opposed to something that's practical. So political decisions are ones that are made for their own self-interest, and it doesn't really take into account the scope of what the team wants, much less needs. A practical development practice are things that we're going to use because they work. They're tried and they're tested, and they take significantly less time to get off the ground, as opposed to investing in a lot of other infrastructure that may not even be necessary and would overbuild the system beyond what you needed. And the other issue that comes to mind within the tech stack is technical debt. It's very common within organizations to have this, but this is one you can't skimp on with machine learning. You absolutely need to keep track of it and take it into account before starting down the path of building your first model within the business. Beyond that, I want to have a quote from Ben Franklin in here tonight. Just by failing to prepare, you're preparing to fail. And what I mean by this is that if you start having all this preparation ahead of time and you start evaluating where the company and organization currently stands, there's a significantly less chance that your projects are going to fail. Additionally, there has to be a lot of discussion around the hierarchy of needs, the data science hierarchy of needs. And what this is really the hiring practices and who you need to hire in the general order from the bottom of the pyramid straight to the top. My day generally, as do others, starts and ends with data. And in order to go and get access to data and get it in the format that I need and getting it quickly, there's a lot of other people within the organization that need to be in the loop in order to make this happen. The case in point is that you need people that are infrastructure engineers and data engineers who are going to know how the data gets from point A to point B. Oftentimes with the data engineer, we're talking about doing work within SQL databases, making sure that the data coming into tables is consistent and making sure that it's been cleaned. You'll often hear data scientists and ML engineers talk about cleaning the data and having clean data. What that means is it's taken from its raw form into a transformed, cleaned form that they're able to go and access. Once that's in place and you have the data in that spot, that's when you can start to begin to hire data scientists and data analysts. You have the infrastructure in place for them to go and access the data and to start working with it. And the one aspect of this chart I would change is that the ML engineer can be, I would argue that the ML engineer can be lumped in with data scientist and the data analyst. They are not the only people that do AI and deep learning. That can also fall into a data scientist depending what industry and what company they're working at. So if you're wondering who to hire, and what should I be looking for in my first hire? If I'm starting a business or the business that you're in is at the point of being ready to hire a data scientist or a machine learning engineer, who am I looking for? Oftentimes, we see a lot of job descriptions around wanting the world of a candidate, having vast amounts of experience in a variety of software and infrastructure tools. My argument is that it's an incorrect way to go about the hiring process. You want someone who is experienced, but you need someone who's a combination of the three things in this pie chart. Someone who's good at machine learning, meaning that they understand the algorithms, the statistics, and how the models are working. You also need someone who's good with communication. It's one thing to be able to program really well. It's another to be able to communicate really well, not only to the engineers, but also to the other non-technical stakeholders. By that, I'm talking about marketing, product, leadership, and others. And that third facet that I would look for in hiring my first candidate would be cloud computing. Now, the reason for this is because if you have someone who understands how to program, is a great communicator, and has some exposure, they don't need a lot, they just need enough exposure to the cloud, that is someone who is very, very valuable because they're able to go and program, communicate, and take something to production. And with your first hire, it's critical to make sure they know how to get to production in some way. If they don't, the model that's sitting on your computer is just a proof of concept. It's not able to go and deliver the value that the business wants, and it's not able to garner any learning which facilitates iteration down the road to improve the model long term. Regarding technical debt, this is a photograph from a paper Google released a couple years ago called The Hidden Technical Debt of Machine Learning Systems. The black box that you see on your screen in the middle is ML code, which, put a different way, is how much time a data scientist is spending modeling and dealing with algorithms. The other boxes that you see on your screen are what I would characterize as your proportion of time spent on the problem. So if you notice, the ML code box isn't really that large, and I can tell you, of the years I've been doing machine learning, I can tell you that this is true and it is valid. I spend way more time dealing with the infrastructure and getting everything else right to make sure that it's in place so that running the code and working with it is substantially more stable. In addition to that, you also see from left to right, you have the configuration, the data collection, making sure you have the right data and a lot of it. Data verification, making sure that your data is actually valid and it is correct. Feature extraction, which is getting the features for a model. So feature, for folks that don't know, is if you were looking inside of an Excel spreadsheet, it is a variable or a column, you could say, within structured data that's going to be used as an input to the model to try and predict the output. And then beyond that, you see some other aspects such as process management tools, analysis tools. Those would be things like visualization software such as Tableau, Mode, anything else like that. And then the serving infrastructure, which is how that model is going to go into production. And then beyond that, you have monitoring. As I previously mentioned, the monitoring is going to show you how the model is actually performing so that the data scientist has the revolving door of feedback. It's not just going into production. You actually have the ability to go and see how the model is performing and what exactly it's doing. Now, in terms of what to expect from leadership, if folks are in a management position, but they're looking to hire people under them, from those I've talked to, the mark of a good manager and the mark of someone who's going to hire the right people is someone who's really high in direction and autonomy. So what this means is that if you are able to give your staff and the people a lot of direction and autonomy, what it means is that you give them the guidance on what they need, but also give them the freedom to do it. Now you contrast that with, say, you give them all the direction, but no autonomy. What ends up happening is you end up being a micromanager and you end up becoming more of a political developer and not practical. Additionally, if you're high in autonomy but no direction, that's also a recipe for a disaster. If you end up giving them a lot of autonomy but don't provide the direction about where the business is going or the problems that need to be solved, it's not going to work, and the project is also most likely going to fail. There needs to be both within management and within leadership in order to facilitate successful machine learning projects. With all of this background, I wanted to get into MLOps. But before I do, if anybody has questions, I'll be checking the chat for about a minute. And if anybody has questions, I'll just answer them both now and at the end. If you don't have one now, feel free to ask one at the end. All right, so no questions just yet. That is okay. We'll just move right along and start diving into what MLOps is with all of that background. Really, what MLOps is, if folks that don't know what it is, you can think of it as DevOps and machine learning combined. A lot of folks are familiar with DevOps and a lot of practices around that with respect to software engineering. You can think of MLOps as the same idea applied to machine learning and AI. And what you start to see within the diagram that I'm showing on my screen right now is the general dev cycle of machine learning, where within development, you're going to be shooting out multiple types of models. You're going to be pulling out the data from your data pipeline, generally from a database, potentially from an S3 bucket or a data lake, and then also being able to have a CI/CD pipeline, meaning that you're able to go and ship everything consistently that's been tested and validated. And then from the operational side, you have the model inference, the monitoring and management, again, being able to serve the model up into production so it can start doing what's expected, but also being able to monitor it so that it can be quantified at how well it's doing its job. For folks that wonder, and for the students I've talked with, new graduates I've talked with, and people that are just starting out in industry, I get asked a number of questions, but a lot of them are around why does MLOps matter? And the answer is because deployment is never the end. Deployment's never the end of machine learning, much less software on its own. Once you've built the model, it has to go to production in some form. And MLOps helps provide those guidelines for that full life cycle. And why it becomes significant is because there's a VentureBeat article. It's not the only article discussing this. There are many others talking about how 87% of the machine learning projects of the companies they surveyed failed to reach production. And this is what I mean by projects failing. It isn't an isolated incident among some companies. It's very prominent and, dare I say, perverse, because there's so much that it takes to get just one of them up into production, to scale it and maintain it. So when I start seeing articles from VentureBeat and from others about how upwards of 80 to 90% of projects are failing to reach production, it's one that I believe because I've experienced it and have had to deal with it both internally and also with talking to my peers and my own network. The other part about MLOps I'll mention as we start going on here is that there are a substantial amount of tools. There's over 200 tools around MLOps to facilitate things like monitoring, management, infrastructure, deployment, you name it. There's hundreds of tools that can be hooked into the pipeline in order to make it that much more successful. So really, what does a workflow look like? What does a workflow look like for someone like me, for a team? How does that entire workflow end up looking? Well, for starters, it starts with data and building the model like I discussed, and then offline, you're going to be evaluating and experimenting with it to make sure that it's actually working as intended before you send it into production. For folks that don't know, within machine learning, when you're training a model, you have what's known as your training data and your test data. So your training data set is what the model is trained on to go and understand. It's the data that's used to understand how to predict certain outputs. The test data is what can be considered a holdout set. It is data that the model has never seen before and is meant to be an evaluation of what the model would do with data that it's never seen before. And if the test data validation metrics start coming back as correct, then it's time to start going to production and figuring out how to go into production and keeping that constant in your head. That's when you start being able to build the infrastructure, building the testing around that to make sure that the infrastructure and the model is going to be stable. And finally, being able to go into the deployment stage, which is the CI/CD pipeline and continuous deployment, and being able to deploy it in a way, again, that is stable and maintainable. And finally, after that, you start having monitoring and observability. As I mentioned previously, you want to be able to monitor what the model is doing. And if something is going wrong or the metrics are incorrect or they are drastically off from what's expected, you need to be able to monitor that and understand. You need to be able to understand how to get those metrics out so that you can go back and understand what the model may be doing in production relative to the data that's being given. So before I get moving any further, I'm going to stop again for a minute, and if anybody has questions in the chat, I'm more than happy to answer them. All right, so no questions just yet. That is totally fine. We'll just move right along into the demo. So the background to what I'm going to show you all tonight, really what does a full MLOps pipeline look like and what to expect. I'm actually going to be showing one of my classmates' projects that I ended up refactoring, which is a ski run recommendation system. And when I was enrolled at Galvanize, I ended up working with her. I worked alongside her within Galvanize. The project, to be very clear, the project is absolutely 100% hers. She was the one that came up with the idea. I was just someone that refactored it a couple of years later. And I had contacted her about a year after completing Galvanize and really liked her project to begin with and said I'd like to refactor it. And I had told her that this is probably going to be a ground up revision. She was totally on board with it. She loved the idea around it. And the goal was to just make her project refined, not reinvented. Now, the reason I liked this project so much is because there's a web app that she ended up building on top of the recommendation system, which makes it that much more digestible, and it's one that people can play with not only just on the website within the chat, but also whenever you like. So my goal when I started working on it was not only the refinement and adding a couple of features into it, was increasing maintainability, meaning that if anybody wanted to pull down the code base and start working with it from beginning to end, could that actually be done? Could you set it up based on what's in a README and the instructions around it with very little pointing and clicking within the AWS console? The additional bonus when I talked with her initially was I was nearing completion of the project and getting it done for her. And she had sent me a message saying, could you look at reducing AWS costs if you have time? And I just said, of course, I'd be more than happy to do that and figure out how to reduce them for you. So before what ended up happening, really what the code base looked like early on was there was a lot of what I'd call legacy code. What this means is that there was a lot of manual processes that happened early that I'm not going to show tonight, but what she ended up doing early on for the ski run recommendation system was in order to go and get the ski runs, she actually parsed text from PDFs and then used one script per major resort in Colorado to go and format that data. So it really wasn't as reproducible as it could be. And it was very cumbersome to go and maintain. In addition to that, there were a couple of aspects that were missing that I really, really wanted to go and put into the code base. One of them is environment parity, which means Docker, so that it works both on your machine and in the cloud in any capacity. Automating the architecture, which means doing it and creating the architecture within a service like CloudFormation so that you can stand it up and shut it down in a version-controlled format. And also introducing test coverage so that anything that's being done within not only the API, but in any of the pre-processing steps is covered. It's doing what's expected, and you can measure that and gauge it within the CI/CD pipelines. And then finally, that last one is AWS cost, because when I started going into her console and looking at the AWS bill month to month, often what I started to see was that it was over provisioned. I'm guilty of doing this as anybody else. It's very common. to go and do that. So the goal was to dial in the resources and end up making sure that it was cost effective as well as stable and maintainable. So after, what ended up happening was I was able to get it working on Docker and AWS Fargate, which you're going to be seeing shortly. For folks that haven't seen Fargate, it is effectively serverless Docker. The Docker image is running within Amazon Web Services, but it's not a physical server that you yourself are managing. Additionally, it was simplifying the code base. Within Python, the goal was one class per process, so that includes pre-processing, web scraping, and the eventual modeling of the recommendation system. Fully automated architecture, which means that you're not going to see anything. You're not going to see anything being pointed and clicked around within the AWS console. And then the additional benefit was I was able to reduce the AWS cost by around 55%. I think I can actually get it a little lower, having looked at the architecture the last week. But in short, now the architecture has now moved from costing about $115 a month to around $50 all in. So before I continue, I was going to say there's a question from Trent Fowler. What are the biggest challenges faced by companies trying to get solid MLOps pipelines in place? That's a good question. I think that the biggest challenge that I've seen would be it's estimating the amount of time, or more specifically, underestimating the amount of time that it takes to get something to production. I think a lot of companies think that they can hire one person and start the process off, and think that by hiring only one person, that's all they need to do. And by hiring one person, it'll go to production within a decent amount of time. Oftentimes what I see is that's further from the truth. One person does not make a company. One person does not make an organization. One person cannot take it to production alone. It really is hiring the right person. As I mentioned, someone who's experienced, but it's also making sure that they are in the loop with all the other stakeholders in the organization. You want to be sure that they have that clear line of communication between everybody, meaning the software engineers, product, marketing, and understanding those levels of expectations and making sure that it's clearly communicated. The last thing you want is getting surprised at the last minute and having to spend even more time on something that could have been rectified days or weeks earlier. So another question I'm seeing here is from Andy E. How do you like to test ML-based features running in production behind toggles and flags, running in a staging environment? What works there and what doesn't? Another really good question. So what I will normally do, and what I've seen other teams do, is you will take the model and you will deploy it to a staging environment with that data that you've used to train, not that you've used to train the model, but you start testing it with other data within your system in the staging environment to make sure that it's working. You also would be wise, depending on the company you work for, to stress test these things to make sure that it can auto scale correctly. So running some type of chaos engineering simulation like Netflix has talked about before is important depending on the size of your business. It's not always necessary, but when you start having a large customer base, it is very important to do that. In terms of what works and what doesn't, so if you're testing on a staging environment, this would assume that the data is static. The data is not coming in live. So what works there and what doesn't? Well, what can happen is very often you can test on the data within your staging environment and get a sense that it's working correctly and the performance is good. It's only when you start going to production that you start to realize that with the live data, the model might be off or it's not as good as you thought it is. That's a combination of both overfitting and just the general process of things. The benefit of doing this, though, is you get to test in the closed environment. However, you're not going to know for sure until you go to production. I hope that makes sense. Additionally, the other aspect I would mention about that, how do you test ML-based features? Depending if you're going to, if you want to introduce another model to production, or you have one that you want to shoot out, that would also facilitate something like A/B testing, where you put two models in production, one of them's the control and the other is the test, and you start to see which one does better. So that's also one that I've seen be difficult within running and how to test ML-based features. You can obviously do it offline with validation metrics like precision, recall, F1, RMSE and MSE, and a number of other metrics for regression and classification. But those are the largest things that come to mind right off the top of my head. So that being said, I'm going to move right into the demo. Actually, before I go into the demo, I'll actually pull this back up. This is another part I wanted to discuss because you're going to be seeing a lot of things very quickly within the time that I've got. So really, what does the architecture generally look like, and what are each of the services I'm going to be working with? So the two that you're not going to see are Route 53 and the load balancer tonight. They do exist and they are in the architecture. I'm not going to spend too much time on that. The things I'm going to be spending time on showing people tonight is within code pipeline, which is really the pipeline about how something is going to work in a CI/CD setting within AWS for machine learning. Within code pipeline in this architecture, you're going to see a GitHub repository being called, which is mine. And then that request is then sent out to code build. What this means is that code build is going to build the Docker image. It's going to run the tests. And if they pass, it's going to push that out into production. And that's going to be done via code deploy after the model has been pushed to ECR, which is the version controlled Docker images that are going to be used in production. And that is going to be sent out onto AWS Fargate within the API cluster and making sure it works. And then also having those logs be streamed out to CloudWatch. And again, this is the baseline architecture I'm going to show. There's some other future steps I'll be showing a little bit later that I'd want to do. So first, what I want to show is this is what's running on my local machine. This is the local web app that's running inside Docker. And what I want to do is I will actually change this to say AWS presentations. There we go. So this is what I would want to display in production. I'm going to simulate how you would push the model out into production tonight. So let's say this is what it's going to look like. I want to go and commit that, and then I want to watch the pipeline start doing its work and deploying to production. So first, what I'm going to be doing is just adding this in as a git commit. And now, once that's been committed, I'm going to be pushing up to my branch. So now we'll go over into Amazon Web Services. These are just the three stacks that I've stood up. Folks that are coming in may notice that one of this says rollback complete. The last time I had done this, for whatever reason, some of the infrastructure hadn't been deleted. And when I went to go and stand it up again last night, it ended up erroring out. However, I was able to get the infrastructure up. It will be working in the repository. So now I'm going to go over to code pipeline. And what you start to see is that you have GitHub, which is linked to my GitHub repository I showed you a few minutes ago. And you also notice that the commit message, and the commit for that matter, is the AWS presentation demo. That information is then sent into code build, which we can watch build. And once that completes, we'll be able to see it go through via code deploy. While this is building, I can answer a couple of questions here. So another question from Trent is, do you have recommendations for a person who wants to future-proof their career by becoming more cognizant of MLOps? Many companies don't have such pipelines in place, so how do we get practice? It's another good question. So I will tell you that the practice that I initially got as the single data scientist at Meet Mindful was, it was trial by fire. That is a terrible answer to go and give. In terms of those that are looking to practice, what exactly does that look like? One I would start suggesting is build a machine learning model locally with a toy data set of some sort. And then what I would start doing is trying to put it on Amazon Web Services in the form of a web app or some type of service that you could call and do the things that business would expect. So what does that mean? That would mean making sure the API and the service for that matter is up. That would mean being able to record the metrics either to a database or another service, whatever that might be. And using all of that together to start building out your knowledge base. To what you're describing, Trent, and what you're asking is that you are correct that a lot of them don't have such pipelines in place. That is one. The other that I would also suggest is you start Googling MLOps in production, and you're going to start getting a slew of articles within Google that are generally very good about how both companies and people have taken things to production in the past. So the question underneath that is from Doug Johnson. I know I'm a couple of sections behind, but one, what are some ways you have found to best explain to technical or semi-technical people what machine learning is and isn't, and what it can and can't do? To that end, the biggest aspect that I do initially is show the level of expectations and really managing the expectations, because people have this idea in their heads from that are the non-technical or the business end of the company have this idea of what machine learning is in the form of these super AI computers, when you have to dial it back and you have to ask them a more important question, which is, what does your business need with respect to machine learning that the business doesn't already have? Very often what machine learning does for your business is it gets you past what I'd call the glass ceiling. You know that there is way more value within your data and there's way more insight, but you're not sure how to reach it. When you start getting to that point, that's when you know it's time to hire somebody for the job. At the same time, in order to communicate to technical and semi-technical people what it is, I start drawing on real world examples for what the model is doing. So a great example with things like computer vision models are really, really good at image classification. So what I try and explain to people is that the model is trying to simulate human vision. So if I showed you photos of a cat, a dog, of a pumpkin, of a spoon or a fork, whatever those images might be, you can recognize that. And the model is essentially doing the same thing, just in a mathematical form. You notice that I'm not getting too technical with that. I'm trying to communicate it at a high enough level, similar what I would call is the iceberg communication, where you give them the very tip of the iceberg in terms of what the model is doing at a very high level. If they have questions, they're going to ask them. You do not have to give them all the information at once. And the second question from Doug Johnson, what are some ways you encourage developers that ML can be super deep topic and yet an approachable technology for many developers? How I explain that to people is that to your point is it is a very deep topic, but what I also make mention of is that you're not going to be an expert at everything. There's way too much to learn, and you can't possibly learn it all. There's too much information and too much research that comes out at any one time to be an expert in everything. So in terms of being an approachable technology for developers, what I start telling them to do is start simple. Always start simple and start with the fundamentals. It's like learning to ride a bike. You need to start working with toy data sets and training wheels, metaphorically speaking. You do not need to start with these multi-terabyte data sets because it's going to be fairly problematic for someone with no experience to try and pull that data in, trying to build the pipeline, and trying to even just train the model once you've even got the data in a space that you can work with it. So it can be really hard to go do that. So I encourage people when they do is when they want to start getting into this topic and understand it, because of the fact it could be deep, is to start simple. Start with the initial algorithms that everybody learns, like linear and logistic regression. Start working your way into ensemble learning, random forests and gradient boosted classifiers. And then and only then start getting into things like computer vision and deep learning, generative adversarial networks. And I say that because of the fact that if you don't understand the fundamentals, it's very difficult to understand the more abstract and complex models. To your third question, do ML processing instances scale greatly based on the number of users? They can, depending on what you're working on and depending on what service you're using. So SageMaker is one I don't have as much experience in. With things like ECS, that is one I do, and they can scale based on how you've architected the solution. So there's a few ways to work with auto scaling. One of them is you can look at things like CPU and memory utilization, which is one. Another you can look at are the incoming requests through the load balancer. And if there starts to be a huge amount of requests, then it's definitely time to start auto scaling. Regardless if it's a spike in traffic or if it's constant, those are a number of signals you can use to start off with in terms of scaling the application. To Mohammed Sawyer, where does the training happen? Training happens either locally or within the cloud. It's either or based on the Python environment you are working with. If you have it in Docker, it's not going to be an issue. The training can happen on any computer provided you have enough power for the data that you are looking to train. So the training happens locally on your computer or any server that you are working on. Shimin Zhang, are there any MLOps blogs, podcasts, newsletters that you follow similar to Import AI for ML? This is a good question. That's one I can put in the chat later, or we can send out to the meetup group, because there are a couple of them that I could look back in my notes and could provide to people. So the other question from Mohammed Sawyer, shouldn't the training be part of some ops process? Absolutely. And it is absolutely part of the process. Within one of the slides I showed, you would see training and evaluation. That is where it is within the ops process. It's absolutely within the ops process when doing that. It's never outside that process purview, so to speak. So you'll notice that it's been pushed up successfully, that all my tests on the computer have run. If I go over to ECS, here's the cluster and the service, and you'll start to see two tasks. So I believe this was one that was previously stood up. Let me go back and take a look at the second. So you'll notice that the task is currently running, and there's the public IP that I want. Again, in production, you would have it behind something like route 53. This is behind a load balancer currently, but if you wanted to route this correctly and not having to use an IP, you'd be doing this through route 53. So what I'm going to do is paste in the IP address and port 8080, which is the port that's serving these results through Flask. And there it is. So now this is running on the cloud within AWS Fargate. So now what I want to do is find trail recommendations to show you what this application can do. Choose a resort I've previously skied at. I'm going to select Steamboat, a trail that I liked in the area. Being a skier myself, I'm going to select Shadows. The resort where I want trails recommended, I'm going to choose Vale this evening. I want the top 10 recommendations, recommended trails. Since I'm experienced, I want black and blue trails, and I'll recommend. And here are the recommendations. So if you're wondering, if people are wondering, why did this recommendation system only give black recommendations as opposed to intermediate? This is the trade-off within things like recommendation systems. They're difficult to train, they're hard to validate, and they don't behave like anything else in production. However, based on what is done on the back end with recommendation systems, there is some explainability behind this. That being said, if I were to go back and just select blue, you're only going to see blue runs. The recommendation system, based on what I want, believes that through how it's been filtered on the back end, it believes that these are the best runs based on what I want. And then furthermore, within the web application, you can look at the map of the area, and you could go to the trail report if you so choose to. If I went to the mountain recommendation system, again, I will go to Steamboat, and I will also select Shadows once again. What this system is going to do is it's starting to recommend other resorts, not trails. So again, I want 10 resort recommendations. And it starts stack ranking the best resorts based on what I've skied in the past and what it thinks I'll like. Some of you may have seen that those images took a few seconds to download, and the reason is because they are hosted within the Docker image. If you were doing this in production, you could very well do this within a system like CloudFront instead, so that these things were cached. It's one that I'm not going to talk about this evening, though. So what you see within the system is that it's recommended the top 10 resorts, not trails, and it's able to go and give me the output of the percentage of runs that are green, blue, black, the lift ticket price in 2020, and a few other key pieces of information within that. And it also displays the previous run I selected with the original metrics. So like I had mentioned, this was something I was working off of my own branch in GitHub. If people want to take a look at this, I will mention the pull request has not been merged yet, but if people want to actually look at this, I will go and put it in the chat shortly. I'll put the link into the original recommendation system because Karen is the original developer behind this, and she absolutely deserves all the credit. I merely refactored it to make it a little faster and a little more cost efficient. So you'll also notice as well that I wasn't really touching anything, and that's also what I'm getting at when I had mentioned that I don't want anybody that's in the loop except for the evaluation. I want to make sure that this is done from beginning to end with no human intervention. Very often what I start to see is people will start manually deploying things, which is really, really dangerous because you don't know what exactly could happen. You don't know if you may have included encrypted keys in the Docker image that you didn't mean to. The list of problems goes on and on with that. By being able to have it being a fully integrated pipeline end to end with no humans in the loop, excluding with monitoring, that is super important, and it's very beneficial, because once you get it right, there's the potential to duplicate it for other projects, especially when you start seeing what was successful and what wasn't with the first deployment. So the question from Trent Fowler, did you use PCA, NMF, or any other feature transformations? What were the features that most contributed to predictive success? It's a good question. So for this system, it's a content-based recommendation system that's using a cosine similarity calculation. As I mentioned before, this original system also used content-based filtering. And what I had mentioned previously in the slide was I wanted to refine but not reinvent it. If I was going to build something that was reinvented, I could potentially use other algorithms. In terms of what was the most predictive, I think it was the type of runs. I think it was elevation. Elevation was definitely one. The difficulty of the runs were others, because it's going to be picking up on that signal based on what you want recommended to you. Off the top of my head, when I first trained this, I recall those were some of the features that were generally noticeable, and they started to serve better recommendations as well. When I started looking at it, the recommendations were objectively better than the previous baseline. So that being said, I want to go back to the presentation and close us out. So into the future, what does this rec system look like long term? If I were doing this in production at a company, what exactly would this thing look like? One of them is that I want these metrics recorded to databases. So what that means is I want those selections that they chose recorded. I want their recommendations that the model returned recorded alongside those selections. And then I want to know if they did things like clicked a map. Did they look at did they start using the rec system again and have that recorded? The reason why is because this is a content-based recommendation system, and the benefit of these is that they solve a problem known as the cold start problem, which is oftentimes with rec systems, you can't start giving recommendations accurately until you have some level of signal or data about that person in particular. Long term, when you have this type of data, you're able to build out a collaborative filtering recommendation system, because you have users who've clicked on items, those items being ski runs. Longer term, beyond that, you can enhance that and supercharge it into a hybrid recommendation system. What this is, it's a combination of collaborative filtering and content-based filtering, where you can take the output of both and build a recommendation system built from two. What this does is it gives you the best of both worlds. Despite being computationally expensive, you're able to go and solve the cold start problem, but also have a more robust system with the collaborative filtering side of it. The reason that matters is because content-based filtering can be highly customized and give very, very, very specific recommendations within the recommendation system. If you want that, or it's geared to that, it's a great starting point. When you want to start going longer term, a hybrid recommendation system could very well be the future once you start recording this data. But again, it cannot happen until you start recording that data and looking back long term at it. So in terms of the team practices, if I'm looking to hire a team or within the organization, what are the things that I start looking at? Someone asked a question similar to this, and I can expand on it within this slide. The first is you want to begin with the end in mind. What that means is you need to be thinking about production and how the model is going to go to production. Those that have experience are going to know this better than others. You need to understand not only how the model needs to be served in production, does it have to be real-time, batch processed, can it be run offline, how is it going to scale, how are you going to monitor the metrics, etc. Second, standardize your practices. What this means is find the best development practices that work for the team. Oftentimes you can ask the software engineering team what's worked and what hasn't, and take those practices with you within machine learning. and start using those within that team itself. Document early and often is number 3. What I mean by this is be able to document not only your results, but also be able to explain what and why you were doing certain things. This calls back to what I talked about earlier about hiring certain people that have great communication. Great communication can manifest itself in the form of great documentation. I've discussed with people before, I've had it in my head for quite some time about how if I hypothetically got hit by a train, could someone pick up where I left off? Could a team or a new machine learning engineer pick up where I left off? And if the answer is yes, then I've done my job with respect to documentation. Next is to pay your technical debt. What I mean by this is to monitor it and understand where there might be bottlenecks and dangers lurking in terms of what could pose problems. It's also worth mentioning that technical debt is different than a bug. A bug is normally something that either doesn't have an exception, there's an edge case that occurs within production and occurs within the system that could be a minor issue. Technical debt is something that is incurred longer term and is much more insidious, but being able to look at that in terms of where your machine learning infrastructure is right now, and if there are any problems that are currently happening, anything you might foresee, it's worth getting out ahead of that and facing it head on immediately, as opposed to kicking the can down the road, because when the time comes to change it, it can be that much harder and that much more time consuming. And it takes away from what you really want to do, which is either generating more value through what you're doing, and it also prevents a slower development cycle. And that last aspect I want to talk about is allocating time for test coverage. Very often, what I see a lot of teams do that they skimp on is they do not write test coverage. That is extremely dangerous to not do that. You need to allocate your time to test coverage at some point, both when you're testing, when it's in a staging environment, before you go to production. I say this because per this presentation, you want everything fully automated. You want these things tested to make sure that you're getting expected outputs and that both the model and your infrastructure and the functions behind it are doing what's expected. You cannot purchase peace of mind when you start thinking about if I should forego test coverage to push something out to production. Don't ever do that. Always make sure you have robust test coverage to make sure it's doing everything that's expected. Within the cloud, what are some best practices I can impart to you from what I've learned? First is to shut down idle services. It's very easy to turn a lot of things on and not turn them off, and it can cost you a ton of money long term, especially if you don't have any billing notifications. Second is to start small and scale up. By that, I mean to start building a model maybe with a few thousand rows of data, just to start gaining some appreciation for what the model is doing and just to get something off the ground. And by scaling up, that's when you can start introducing more data and start to make the model that much better. When you start building your first model, it's never going to be good. That's what iteration is for. And you can start iterating based on either more data, changing the model, but making sure you start small just to make sure you have a working pipeline early on is super important. Tagging and logging all services is the third I would advise people to do. And by that, I mean having tags such as your name, product, service, and department to make sure that you can trace these costs back to whatever is running. If you don't do that, it becomes very, very difficult to figure out what is costing you the most money within your cloud environment. Next is to not ever use env files in cron or production. So for folks that don't know, an env file is an unencrypted file that normally exists locally in your IDE that includes your passwords, API keys, and other sensitive data. My advice is to have this stored in the parameter store or the secrets manager, depending on the type of key that you're working with. I say this because the parameter store and secrets manager are version controlled, so you're able to change them as necessary. And if they are deleted by mistake, you always have the ability to go and get them again and change them again if something ends up going wrong. When you start using them in cron or in other situations, it ends up being unencrypted and just a very bad practice to go and have within both your team and within the infrastructure. You don't want someone getting access to your API keys that was unintended. The fifth and final aspect I have is to know your range. Just understand and be honest with yourself about what you don't know and what you do know. And because when you start focusing on what you don't know, that makes your skill set that much stronger. And it also makes you understand what you may want to learn, what you need to learn, and long term is going to make you a more successful developer. And finally, I want to close out with this, that everybody's the expert until it's time for production. The amount of phone calls I've had, the amount of meets I've had during the pandemic alone, the number one question I get is really, what makes me valuable to an organization? It's being able to get something to production. And I say this because, as I mentioned previously, until you've gone to production, it's a proof of concept. It's not actually delivering what's intended. It makes you that much more valuable, and it makes you that much more desirable as a job candidate. It's one thing to be able to go and develop the models locally and to get it working locally on your own computer or a cluster or an EC2 instance. It's another to throw it over the fence and have it start interacting with the other things within the business cycle, within other software services to track things, and within other departments that are also looking for what these things can deliver.